The control system compares the called-for fuel flow to the actual rate of flow sensed by the magnetic speed pickups. When the demand for fuel increases, the control system begins to close the bypass valve. As the bypass valve closes, more fuel is forced to the flow divider. During gas-fuel operation, natural gas is fed through manifolds in the end cover of the multi-nozzle combustor to each fuel nozzle. The gas fuel enters the combustion chamber through metering holes in the gas tip. The gas tip assembly is designed to impart a swirl to the combustion air to optimize combustion and provide smoke-free operation. From ignition to full load, the control system modulates the bypass valve in response to feedback from the magnetic speed pickups and the fuel demand. The position of the gas control valve is modulated in response to the total called-for fuel flow. As the turbine is loaded and demands more fuel, the control system increases the stroke of the gas control valve. The gas-fuel pressure transmitters provide a signal that is proportional to the operating pressure between the stop-speed ratio valve and the gas control valve. If the P2 pressure starts to change, the control system adjusts VSR-1 to maintain a constant inlet pressure at the gas control valve. Atomizing air and liquid fuel are injected into each combustor through a liquid fuel nozzle. The atomized fuel is ignited by a spark plug. Once the reaction is started, the combustion process is self-sustaining as long as fuel and air are available. When normal trip oil pressure is established, VH4-1 allows hydraulic oil to flow to the actuator of the liquid fuel stop valve. The stop valve opens and liquid fuel flows to the fuel pump. Once 33FL-2 signals that the liquid fuel stop valve is open, the control system energizes the solenoid of the liquid fuel pump clutch. The clutch is engaged and the fuel pump is driven by the accessory drive gear. Fuel flows to the bypass valve and the flow divider. The flow divider sends an equal amount of liquid fuel to each combustor. Magnetic speed pickups in the flow divider sense the rate of fuel flow and provide the control system with signals proportional to the amount of fuel being sent to the turbine. The major parts of a typical servo valve are the torque motor, motor armature, jet tube, spool valve, force feedback spring, and fail-safe bias spring. Fuel is injected into each combustor through a gas fuel nozzle and is ignited by a spark plug. Once the reaction is started, the combustion process is self-sustaining as long as fuel and air are available. At the required point in the starting sequence, the control system actuates the SRV dump valve and the SRV servo valve. The dump valve allows hydraulic oil from the servo valve to flow to the SRV hydraulic actuator, and the stop-speed ratio valve opens. The P2 pressure is gradually increased at a preset rate as the turbine is accelerated to 100% speed. Once the turbine reaches full speed, P2 pressure is maintained at a constant value by VSR-1 regardless of the gas control valve position. When the gas-fuel pressure transmitters sense that the area between the stop-speed ratio and gas control valves is filled with fuel, the control system actuates the GCV servo valve. This allows hydraulic oil to open the gas control valve. Gas fuel is delivered to the combustors and the turbine is fired. During liquid fuel operation, fuel oil is fed through the fuel oil cartridge and is injected into the combustion chamber. Atomizing air is fed through the fuel nozzle and impinges on the stream of fuel oil, breaking it up into a mist of fine particles to optimize combustion. In order to change the type of fuel during turbine operation, the control system initiates a fuel transfer. In this example, the turbine is operating on liquid fuel. When the control system gets a signal to transfer to gas fuel, the stop-speed ratio valve and gas control valve open and gas fuel flows to the combustors. As the amount of gas fuel is increased, the amount of liquid fuel is decreased in order to maintain the speed or load conditions. Once the turbine is operating on 100% gas fuel, the liquid fuel system is shut down and the liquid fuel lines are continuously purged with air. This prevents coking of the liquid fuel nozzles during gas fuel operation.